All right, this is a bonus topic. This is not an AP topic. This is a topic that you look at Ohio State. When you see something with like an x squared plus probably a square, or an x squared minus a square, or a square minus an x squared with an x, you know, whether there's a square root in there or not, it's probably a key to recognizing that this is really like a Pythagorean theorem type situation. And what we're going to do is we're going to take this x integral and change it into theta integral. So we're going to use a triangle to relate x's and to change this into a trig integral with like cosines or sines or tangents or secants. Then we're going to do the integral with trig, and then we'll go back to x's in the end. So it's like a u substitution, except it's going to be a trig substitution. So here's how this might work. So for this one, if you can kind of think of the Pythagorean theorem here of a squared plus b squared equals c squared, you can think of this as like x and 10 are the legs of a triangle, and then this whole thing would represent the length of the hypotenuse. So let's draw that out for what it might look like. Okay, so all we're doing is making a triangle. And let's go ahead and make this 10 and make that x. If this was 10 and this was x, then this side length would end up being x squared plus 10 squared, which is 100. Okay, so this is just a true relationship for a right triangle, and we'll go ahead and make that theta. Okay, so let's think about what this would be. Let's go ahead and relate. Eventually, we want to know what this is, right there, and we want to know what x is, and we want to relate them to the 10. We don't want to relate those to each other, so we're going to get a trig function that makes x and 10 relatable, which is tangent. So tangent of theta is x over 10, which means x equals 10 tangent of theta, okay? And then we'll go secant, or I mean, if you said cosine is just going to be 10 over this, but really you want this in the numerator. So if you go secant of theta, secant is hypotenuse over adjacent. So that means that 10 secant theta is equal to the square root of x squared plus 100. Okay, we're getting close. If I know x equals 10 tan theta, then I can take and find the differential. So then dx equals 10 secant squared theta d theta. And now I'm ready for my substitution. Okay, so I'm going to take this integral with x's, and I'm going to replace everything. Okay, x, we know, is 10 tan theta. So instead of x, I'm going to write 10 tangent of theta. Instead of the square root of x squared plus 100, I know that's 10 secant theta. And instead of dx, I know that dx is 10 secant squared theta d theta. Okay, now I can just cancel a whole bunch of stuff. So these 10s can cancel, that secant can cancel with that squared, so I get 10 integral of secant tangent, right? So there's one secant and one tangent left. And I know the integral of secant tangent. The integral of secant tangent is just secant theta plus c. But I know what secant is. And in this case, I actually know what 10 secant is. 10 secant is just this guy. So then I go back to x's. Even if that 10 wasn't there, I could still take this and solve for secant. But 10 secant is the square root of x squared plus 100 plus c. Okay? And that's how these integrals work. So you recognize that it's some sort of Pythagorean theorem type pattern with like a square root and an x squared plus 100. In this case, do you see how inside was x squared plus 10 squared? So I knew that those two were the legs, because it was as if that was like the hypotenuse. That's not always going to be true, right? So if it's like x squared minus something, well then, you know, you actually might have x be the hypotenuse. But in this case, this turned out to be a secant and a tangent situation. I changed x's to thetas. I changed the x, I changed the square root, and I changed the dx. I related all of those things based on this triangle. I did the integral in trig, and then I made a back substitution. So no matter what you get here, whether it was secant or cosine or sine or tangent, you can always just look back at the triangle and then replace it, right? So if this ended up being a cosine, it's fine. This sun, the shade today is killing me, and the lights are just going off every time. But if this was a cosine, I could just look up here and still just do cosine. Or if this was a sine, I could just go back and do sine. Okay, so that's kind of my first example. I do want to point out that this particular one, I could have done with just regular u sub. I understand that. I picked an easy one. I did it with trig substitution, but I really just could have made u equals x squared plus 100 and done an old school, and then I get 2x dx, and then what happens, right? I could say then that du over 2x is equal to dx, and then I could have said, okay, this integral is x over the square root of u times dx, where dx is du over 2x, so cancel, bring out the half. This is really just u to the negative 1/2 du. Increase the power by 1, divide by the new power, just makes that this, and then dividing by half cancels that. And then if u is this, then my answer, just doing normal u substitution, would have been the exact same thing as I got here. Okay, so of course, this particular example, I didn't actually need the triangle method, meaning trig substitution. I could have done normal u sub, but that's obviously not always going to be the case. I just picked an easy one that we could show that it really does work both ways. Okay, how about this next one? Okay, if you look at this next one, clearly, you know, and maybe we'll do two. I don't know how we'll have time on the video. I don't want to make the video forever. This one won't be able to be done using u sub. Okay, so let's draw our triangle. See how this is an x squared. This is an x squared minus 4. So if you have to think about this, what's the hypotenuse here? Think about this. The hypotenuse would be x. This is like c squared minus b squared. So make the hypotenuse x. Let's go ahead and make that 2. And then this, the other leg, would then be x squared minus 4. And that's our theta. Okay, so let's go through everything. Again, we want to relate these two and those two. We always want to relate the variables to the constant. So this one's also going to be a tangent and a secant one. This one will end up being a sine and cosine. So then tangent of theta is opposite over adjacent. So this is going to be the square root over 2. I'm just going to go ahead and move the 2 over there. Save me a little writing. So we get that. And then we're going to do secant. Secant of theta is x over 2, so I'm just going to move. Actually, I'll write that one out. Secant of theta should be x over 2, which means x is going to be 2 secant theta, which means dx is going to be 2 secant theta tan theta d theta. Okay, so then I'm good. I can make some substitutions. I can substitute in 2 tangent for this. I can substitute 2 secant theta for x, and I can substitute this for dx. Okay, so now I'm ready to actually do the substitution. The square root of x squared minus 4 is 2 tan theta. X is just 2 secant theta, and then dx is 2 secant theta tan theta d theta. Okay, so what all cancels here? It looks like secant, a 2 and a 2, so that whole thing looks like it's just 2 times the integral of tangent squared d theta. Okay, I don't know how to integrate tangent squared, but I do know that tangent squared is secant squared minus 1, and I actually then do know the integral of secant. The integral of secant squared is tangent. And then the integral of 1 is just theta. Okay, so then my answers are 2 tan theta minus 2 theta plus c, and then I have to think about how this should work, right? Tangent theta, well actually 2 tangent theta is right here, so this is really just, let's go back to x's now. This value is really just the square root of x squared minus 4, and then minus 2 theta. That's the tricky one. So if you come up here theta, you could do it in a variety of ways. So you could say theta is inverse secant of x over 2. You could say theta is inverse tangent of this over 2. It doesn't really matter. There's going to be a whole bunch of possibilities. So let's just do inverse tangent of the square root of x squared minus 4 all over 2. All right, so I use this and I solved for theta. You could have went to the triangle. You could have said cosine of theta is 2 over x. So you could have said theta is inverse cosine of 2 over x and put that in for theta here. All of them would have given you the same answer, okay? Plus c. So we took an x integral, we had a triangle relationship, a trig relationship, in which we found tangent and secant in this case. We found what this was, we found what x was, we found what dx was. We plug it in, we change it to a trig integral that we can do. We do the trig integral, and then we resubstitute either using these values or we have to look back at the triangle. Okay, let's do this last one. Okay, so this is 1 minus x squared. All right, so that looks like the 1 then is the hypotenuse, right? 1 is the hypotenuse. Let's make that x. So then this is going to be 1 minus x squared. That's our theta. Okay, so then I want to relate these two, which is sine. So sine of theta is x over 1. So sine of theta is equal to x. That's nice. Okay, now I want to relate these two. Again, you always want to relate the variable to that. So then you have cosine. Cosine of theta is adjacent over hypotenuse, so it's just over 1. Okay, so then I know what this is and I know what this is, and I can take a differential here to say cosine theta d theta is equal to dx. And now we can make a substitution. So this integral turns into, that's just cosine theta, x to the 4th, okay, that's just sine to the 4th. And then dx is cosine theta d theta. All right, so this one might not be as obvious, because this is cosine squared over sine to the 4th theta d theta. And again, it looks like, oh my gosh, I took this integral, which I guess is not doable, into this integral, which doesn't look very doable. But if you mess around with this, you can rewrite this. Cosine squared over sine squared is really just cotangent squared. And then I have 2 more sine squareds in the denominator that I'm going to flip up and make cosecant squared, because I know there's relationships between cotangent and cosecant, just like there is between tangent and secant. Remember, the derivative of cotangent is cosecant with a negative sign. So if I really put a negative sign there and a negative sign there, then this integral actually becomes negative integral of u squared du. Again, think about why that's true. If u is cotangent, du is negative cosecant squared. So this is really just u squared du with a negative sign. I know how to integrate that. That's just u cubed over 3 plus c. U was cotangent, so this is negative cotangent cubed theta over 3 plus c. And then I have to look back here to figure out what cotangent is. Cotangent, remember that's just adjacent over opposite. So I can do that. Okay, so then I'm going to finish this. So this is really just negative 1/3 cotangent. Okay, so come over here, right? Cotangent. Okay, adjacent over opposite cubed plus c. Now that might look gross, but that is the answer to this question. Okay, so hopefully, I know these are a little tricky, but you can see how you're going to take an integral that looks like some sort of Pythagorean theorem type situation, an a squared plus b squared, or a c squared minus a b squared. You're going to draw a triangle. You're going to use the triangle to relate trig functions, sines and cosines, or secants and tangents. If you end up getting like cotangents and cosecants instead, well, then you just use these rules, because remember, cotangents and cosecants have the same relationship that secants and tangents do. So if you like flip these around in the wrong direction, you might get cosecants and cotangents instead of secants and tangents, but you can still do the integral. The whole point is you're taking this, making a trig substitution to make it a trig integral. The trig integral you can do, and then when you get your answer, look back at the original triangle to then get rid of theta or get rid of tangent of theta, or in this case, I had cotangent of theta. So go back to the triangle and just do cotangent of this over this cubed, and then you got an actual integral with x's. Okay? Hopefully this helps you get started. If you want to do this for bonus, this is not on the AP test, but this will likely be a bonus on my test.